Assalamualaikum warahmatullahi taala wabarakatuh. Well, everybody, we are actually approaching week 8. So today we're going to learn about teaching and learning strategy and its integrations into the electronic learning environments. Even though technology is a tool for learnings, but we as an educators must know how to integrate teaching and learning strategies in the electronic learning environments, such as how to design constructivist learning environments in web-based instruction, in e-learning, through apps and other kinds of technological tools. Before we go into learn about teaching and learning strategies that are appropriate to be implemented in any electronic learning environments, let us reflect back about cone of experience by Edgar Dale. I believe everybody knows about this cone of experience. According to Dale, we can actually divide the learning into two types of learning, which are active learning and passive learning. From this cone of experience, we know that if we're going to focus on active learning process, where the students will actually design, perform a presentation or experiment something, or even simulate a models of experience or phenomenon, if we able to create this kind of learning experience, the learners actually will involve in the process of analyzing, defining, creating, and evaluating. And according to Bloom, this is the highest level in Bloom's that known as higher order thinking. So when we actually moving up to the top part of the cone, then we know that if we only is going to allow the student to read, or we only use lecture styles or one-way teaching styles to the student, where the student only going to hear, view images or watch video, this is actually the low levels of thinking. And if we focus on the passive learning only, the passive learning process only, then only 10% of the informations that we deliver to the student will be remembered by the student. But if we allow them to experience something, to experiment something, then the possibility about 70 to 90% of what we have been teach the students in the class will be stored and remember in their long-term or short-term memory. What is active learning? Active learning is actually any methods of instruction that allow students to actively participate, involve in the learning process to a varieties of individual and group activities. Examples of active learning activities are discussion, presentation, game, worksheet, short reading, short writing, case study, solving a scenario, surveys. This is type of examples of basic active learning activities. If you go seriously in active learning, you can focus on cooperative learning, problem-based learning, or collaborative learning. In the collaborative learning, there are certain models where the student will work together in a small group to complete the activities. In the cooperative learning, student works on individual section of the activity and then compile the result to complete the final activities. Collaborative learning is totally different with cooperative learning. Cooperative learning is more on everybody learn by their own, and after that they cooperate to form a final reports of the assignment. But collaborative learning is where they work together. They have to discuss in the group. So if they swim together. If they actually lost, they lost together. While problem-based learning is where the student work in a small group using the activities to solve a problem. Problem-based learning is more focused on ill-structured problem with more than one solution. And if we're able to do this kind of learning environment in our class, then we can claim that we are actually implementing active learning. Some educators, they confuse about active learning versus flipped classroom versus problem-based learning versus peer-assisted learning, cooperative learning, and others. Actually, how do we differentiate this kind of learning strategies? We have to look into two factors. The first factor is instructor control versus the student control. Active learning is actually a broad learning and teaching strategies that where the instructor control is actually higher than the student control. Along the way, when you move to the right, then you can see that the learning strategy give control more to the students. For example, project-based, studio learning, problem-based learning give control more to the student instead of to the instructor. If you look at the Venn diagram at the below of the slide, then you can see that this is to show the overlappings of all the teaching and learning strategy. You can see that active learning is more general, where cooperative learning, flipped classroom and problem-based learning is actually more specific. So this is the overlapping among the teaching and learning strategies. So in other words, people can say flipped classroom is one of the example of active learning. Problem-based learning also is one of example of active learning. But the other way around, you can't say that active learning is problem-based learning. Okay, so I hope you are quite clear on how to differentiate between these types of learning strategies. Let us discuss in details about inquiry-based learning. Inquiry-based learning is an educational strategy in which students follow methods and practice similar to those of professional scientists in order to construct knowledge. That is why in learning science, inquiry-based learning is one of the popular methods. So in the inquiry learning is more on the process of discovering new causal relation. What makes this happen? And it involves the formulating of hypotheses and testing. Inquiry-based learning is also an approach to solve problems, and it involves the application of several problem-solving skills. And it emphasizes the active participation and learners' responsibility for discovering knowledge. And in the process of inquiry-based learning, students often carry out a self-directed, partly inductive and partly deductive learning process by doing experiments to investigate the relations for at least one set of dependence and independence variables. There are 4 levels of inquiry-based learning. The first one is confirmation inquiry. Second is structured inquiry. Third is guided inquiry. And the fourth one is open through inquiry. So you can see that the confirmation inquiry will involve high teacher involvement compared to the open through inquiry. In the confirmation inquiry, it more reinforces of prior knowledge, where in the structured inquiry, the student follow the sets of process. In the guided inquiry, the student research question only provided, while in open and through inquiry, student does everything. So in the open through inquiry, it's more open, and the student, it depends on the student how they're going to solve the problem. So this is the 4 types of level of inquiry-based learning. What are the benefits of inquiry-based learning? Actually, inquiry-based learning will straighten the concept and knowledge that the student will learn. And from inquiry-based learning, the student will learn to take initiative. They will actually control their own learning process. It will promote the deeper understanding, since they have to explore the problems that have been given to them, and it works anywhere and for all level of students, okay, regardless of whether the student is smart students or moderate students. It allows a varieties of instruction in inquiry-based learning. What are the key components of inquiry-based learning as identified for different researchers? A research has been conducted looking at 5 previous researchers who focus on inquiry-based learning. Then you can see that, like for example, Pedest focus on 5 direct phases. Callison and Baker is actually focusing on 5 foundational elements. Lee, Mormon, and Joel is actually focusing on IBL 5 key steps. Marshall and Horton's explain IBL based on 4 common components. Luera, Kilu, and O'Hagan's actually explain IBL's component based on 5 key components. So you can see that if you search through the internet, if you try to find inquiry-based learning models, usually you will find more on 5E models. 5E model is stand for engage, explore, explain, expand, and evaluate. Has been focused by Luera, Kilu, and O'Hagan. So what is the purpose of this key component? This key component will act as a principle or as a inquiry-based learning process or models that you will use when you're going to implement inquiry-based learning in your teaching and learning. For examples, if you want to design inquiry-based learning activities in learning science, if you want to integrate 5 key components by Luera, Kilu, and O'Hagan, the 5 E models. So how do you design, or how do you actually come up with the activities that will engage the learner? Next to the activity, they will explore more and they will explain their understanding towards the problem, and they will expand their knowledge, and lastly they will evaluate their understanding. So this is how you have to design your learning activities. This is inquiry-based learning model based on Lee, Mormon, and the Jones. It starts with us in designing a learning activities. In any electronic learning environments, you have to have a task where you will ask the student questions. Student ask questions. Then after that, student will investigate on the issues, and they will create, synthesize, make report, and later on they will discuss and share the ideas, and at the end of it they're going to reflect or examine back the result and look at questions again. So this is a basic cycle of inquiry-based learning. Another models of inquiry-based learning is by Luera, Kilu, and O'Hagan, the popular one known as 5E models. So this is the learning cycle that the student should go through. If you claim your learning activities in your class or in your websites or in your apps reflect 5E models. The first, the student will engage. The student are engaged with the challenging situations, with the tasks that you give. Then they explore and investigate the phenomena. After that, the student will explain the cause of the phenomena, and they will elaborate later on by applying their knowledge towards the new situation. And at the end of it, they will evaluate their knowledge and the learning process. This slide explains more about the detailed process and technological tools that we can use in each phase of 5E models. For example, in Engage, we can use video clip, demonstration, kinesthetic activities to engage students on towards the activity. In the Explore phase, where we ask them to test the hypothesis. In the Explain phase, might be they can actually provide interactive presentations, or might be they can actually prepare writings to explain more about the problem. In Elaborates, they can actually do lab experiment, patient-based learning, and lastly in Evaluate, they can actually measure their own understandings by preparing a portfolios, or they going to do a self-assessment on their understanding through reflection. We're done with inquiry-based learning. Now let's move on problem-based learning. Problem-based learning is a student-centered pedagogy. Problem-based learning has been introduced first in medical educations by David Barrows. You know that in the area of medicines, every problem in medical educations is ill-structured. It's not come with one solution. So problem-based learning is something like a process the process does not focus on problem solving with a defined solution, but it allowed for the development of other desirable skills and attributes such as knowledge acquisition, enhanced group collaboration and communication. And as I did mention, it was developed for medical education and has since been broadened in application for other programs of learning. And another terms of problem-based learning, if you deliver it through electronic mediums such as websites or apps and so on, they call it as ePBLs. PBLs actually involve complex real-world situations that have no one right answer, are the organizing focus for learning. The student work in teams to confront the problem, identify the learning gaps, and to develop the viable solutions. And through PBL, students will gain new knowledge through self-directed learning, and instructor only acts as facilitators. and the problem actually the one who lead to the development of clinical problem solving capabilities. Table 2 explain more information on pedagogy in PBL versus pedagogy in traditional lecture, and assessment in PBL versus assessment in traditional lecture, and community in PBL versus the community in traditional lecture. So you can see that this is a difference between PBL and traditional lecture. I did mention on the term of ePBL in the previous slide. Another terms that they use for PBL is OPBLs or online PBL. And Regluth 2008 defined OPBL as learning activities are digitally mediated or online and involve network communication for all problem-solving learning activities. And through OPBL, course does not involve face-to-face instructor contact, and the course also use intentionally ambiguous and authentically complex context-based problem as stimuli for learning, and the course organize learners into small groups for collaborative work on the problem through online learning medium. Like inquiry-based learning, PBL also have specific PBL process or PBL models. One of the popular one is developed by Maastricht 7 jump methods for PBL tutorials. You can see that through these 7 steps, this is the step where the student go through when they solve any problems in problem-based learning. Another models related to PBLs that known as PBL process is formulated by Tan On Seng. Professor Tan is from Singapore in 2003. So you can see that the process start with meeting the problem analysis and learning issues, discovery and reporting, solution presentation and reflection, and overview, integration and evaluation. In between the process, the students have to go through self-directed learning. They have to learn by themselves, by reading the articles, by discussing the issues with their friends and group members. The next learning strategies that we should learn is about personalized learning. The term personalized learning or personalization refers to a diverse variety of educational programs, learning experience, instructional approach, and academic support strategies that are intended to address the distant learning needs, interests, aspirations, or cultural background of individual students. And personalized learning may also be called as student-centered learning. If we considering student learning style in our teaching and learning methods, then we actually preparing or integrating the personalized learning in our teaching. How can we personalize learning? So there are many elements of personalization that you can control. For example, you can personalize based on goals or learning outcomes of your teaching. You can personalize it based on activities, based on time, place, space, based on the modes or formats of assessment or learning activities, based on the networks, whether it involves peers, mentor, experts, interest-based learning communities, or expert Q&A communities or professional communities. You can personalize also based on the types of resources, based on the pace of learning, based on the technologies, based on the content, topic, inquiry, questions, and projects. So there are so many elements of personalizations. Personalized learning. Let us recall back. If we actually teach our student in a classroom, how do we cater for personalized learning in conventional learning and teaching? Can you give an examples of conventional learning and teaching that has personalized learning aspect? Anyone? How do you personalize it? How do you actually make it one-to-one teaching and learning sessions just fit to the student need for that student? If you have a class consists of 30 students, how do you actually prepare 30 ways of teaching to each students? One student with different style, another student with another different style. So how do you cater this? What happened actually? Surprising, you can realize that when in the schools or in the higher ed, when the teachers or instructor cannot cater personalized learning in their class, what happened? The student actually will seek for personal tutoring through tuitions, through one-to-one learning, hired someone to teach them personally. This is what happened. But how do we do that? Believe me or not, through technological tools, we can actually personalize learning through the existence of cognitive system. Okay, this is an example in a Blackboard open learning management system where personalized learning designer can take place. You can see that the process moves from the course starts, and when the class or the course starts, then you can see that the student will receive automated or welcome emails and pop-up message. They will take quiz first, and from the quiz result, the system will actually identify and categorize them to several groups without they even notice that they have been categorized. And then they went through the process where the system will inform the progress of learning, okay, and then they will start to answer questions, and the system can actually do a retention checks and force a redirect anti-completion. Let's say they are not actually achieve the level that we decide to the system, so the system will channel them to other part of the system so that they can learn more, and at the end everybody's going to reach out the finish line. Might be not at the same time, but they will actually reach out to the finish line. To integrate or to implement personalized learning through any electronic learning environments, we need what we call it cognitive system. Cognitive system is a category of technologies that use natural language processing and machine learning to enable peoples and machines to interact more naturally to extend and magnify human expertise and cognition. This system will learn and interact to provide expert assistance to scientists, engineers, lawyers, and other professionals in a fraction of the times it now takes. So the cognitive system will actually learn the learner's behavior. They try to predict what kinds of learning behaviors that will assist the student in learning. With the existence of cognitive system, so we can create what we call it personalized learning system. So the ideas of personalized learning, sometimes referred to an adaptive learning or differentiated learning, is by no means new. It's not new actually. In the physical world, one-to-one tutorship between teachers and students, that is the examples of personalized learning. However, this model is not practical and is not cost effective. What if a system could perform a similar task? What if a system could understand the learners, recognize where they are failing to grasp a concept, and knowing all possible learning options can direct their learning pathway accordingly? So this is where the system can help it. So through data minings, where we can actually mining the online data that come up with from the students or learners behavior when they interact with the system, then the system will try to understand on the online learning behavior, and later on they can predict if future student who would like to get A for this course, they can actually go through this kind of online learning process, which has been went through by the previous students who got A in learning. Hybrid approach. What is hybrid approach? Hybrid approach is a delivery that combines face-to-face classroom instruction with online activity, and this is actually known as hybrid learnings. And for examples of hybrid approach like blended learning, it also can be hybrid between more than one learning strategies. For example, POPBL is examples of hybrid approach, combination of project-based and problem-based learning. CPBL, collaborative problem-based learning, is a combination of collaborative learning and problem-based learning. And we can actually integrate other two learning strategy into one, and it can be known as hybrid approach. And the best model for hybrid approach is blended learning models. This is an examples of blended learning cycles that have been developed by myself. In UTM, we have a group of blended learning headed by me, and then we actually design a 1 or 2 weeks learning cycles of blended learning, where you will start with online learning activities that you give it to the students through the e-learning, and next you will have a face-to-face in your class, the offline learning session with the student to discuss on the task. Then later on you continue to discuss about the task through the online learning tools, online learning communication tools, such as our online learning forums. And then you ask the student to do self-reflections on their learning, and at the end of it, they will have to prepare individual or group reports based on the task given. And through this kind of process, you can actually see 50% will take place online, 50% will take place offline. This is an examples of blended learning model. The first model, known as rotation models, and types of rotation models that we can use is station rotation model, lab rotation, flipped classroom, and individual rotation model. Another models for blended learning is known as flat models. Third is self-blend models, and the last one is enriched virtual models. And few slides after this will explain in detail about each types of blended learning models. Another concept of hybrid approach is actually related to the machine learning. The goals of machine learning is to program computer to use example data of past experience to solve a given problem. So machine learning is a subset of artificial intelligence that help computers or teaching machine learn from all previous data and make intelligent decision. To explore more on machine learnings in education, let us go to this link, and you will learn more how machine learning actually assists education. This diagram differentiates what is artificial intelligence, machine learning, and deep learning. Although we are in the educational technology, slightly we actually implement the concept of this artificial intelligence, machine learning, and deep learning into teaching and learning. The one who concentrate about these three factors or elements in education is the one from the pure computer science. They actually come up with the concept of deep learning, machine learning, and artificial intelligence comprehensively in the area of education. But sadly, sometimes might be they are technical persons, they did not actually well versed about teaching and learning process among students, and this is where some of the concept might be quite impossible for us to implement in education. But if we explore the concept and learn from them very well about it, inshallah actually we can actually implement this concept in teaching and learning. It's very helpful. I experienced some of the basic integrations of machine learning in educations, but not actually as powerful as those from the computer science. So some of applications of machine learning in education, it will support educators. Actually, it will support educators to access all learners' data in one place. It will help to predict the learner's performance. It will test the learner. It will provide a process of assessment where you will grade the student fairly. It will provide customized learning. It will organize the content effectively to cater the needs of different students, and it will improve retention. One examples of application of machine learning in education is chatbot. We're going to experience chatbot later on at the end of our class session. How machine learning is revolutionizing education sector. So few application is caused by machine learning, like for example adaptive learning. It will increase the efficiency, the learning analytics, the predictive analytics, the personalized learning, the accurately grading assignment. This is where the machine learning has transformed the education sector. What is chatbot? Chatbot is chat robot. So the application of chatbot is where the learners or human will actually communicate with the robot. So the behind the chatbot is a database, consists of types of questions that frequently asked by anyone related to certain issues, and it also have answers to automatically answer the question. So chatbot, it has an intelligence behind it, artificial intelligence behind it. Okay, let us try one of the chatbots through the link that I've been stated in the slide, on the slide. Then we will actually experience what is chatbot. Okay, guys, let us try. Okay, we're done with today's topics. Thank you very much, guys, for your attentions. Please actually browse through this slide and takes your times to learn about teaching and learning strategies that we can implement in our electronic learning environments.